Welcome back to the channel. Today I have a very fun video for you. We're going to be going back to the basics on CNC. Now this video is for absolute beginners who have heard those words before or maybe seen some machines around and thought that looks like fun, but they have no idea how it works or what's involved. If you're already cutting things on a CNC machine, then there's probably not going to be much here for you that's new. But for the rest of you, I encourage you to stick around. You'll walk away at the end understanding a lot better what CNC machines are, how they work, and how to get your jobs done. Alright, so let's start off first with what the heck is a CNC machine? You've probably heard a lot of names tossed around. CNC mill, CNC router, CNC plasma table. Well, CNC actually is just a reference to the technology used, computer numerical control, that moves the mechanism around. It's a really, really vague term. Technically, your 3D printer is a CNC machine. Your laser cutter is a CNC machine. CNC routers and mills, of course, are CNC machines. Plasma tables, vinyl cutters, all those things are technically CNC machines. For the sake of this video, we're going to focus on CNC mills and CNC routers. Now, even though you can kind of define them strictly, they get muddy too. Generally speaking, when you're talking to a maker about a CNC router, that is a system that's predominantly used to cut wood. When you talk about a CNC mill, that's generally a system that is much beefier and heavier and intended to be cutting metal. There's lots of overlap. You'll see people cutting metal on routers made for wood. You'll see occasionally people cutting wood on a metal CNC mill. Really, for the sake of this video, you don't need to worry about that. We're just going to be talking about the extreme basics of CNC mills and CNC routers. So let's start with an anatomy lesson. CNC mills come in all shapes and sizes. There are itty bitty tiny ones like this little Tormach here, and there are some the size of entire buildings. They all have some things in common though. Some basic parts that you'll see on every CNC router and mill in some form or another. Some are enclosed, some are not. But what you'll see on almost all of them is there is a bed of some kind and a cutting head that can move around to do the cutting. And by some combination of the bed and the head moving, or maybe just the head moving, you have the ability to cut on 3 axes. Of course, there are machines that go up 5 axes, 4 axes, and more, but again, we're staying basic here. This cutting head here can be referred to as several different things. Often you'll hear the term spindle, which is a kind of purpose-built motor just for being used on these cutting machines. Or sometimes you'll see it's literally just a router, like a palm router you would buy at a hardware store strapped onto the gantry. The tools that mount in here that do the actual cutting are called end mills. They look kind of like drill bits, but the actual shape and geometry of the little cutting edges is different than your standard drill bit. These are purpose-built for the job of being run on a mill to cut materials. They come in a wide variety of shapes and sizes, all the way down to itty-bitty tiny ones for getting super fine details up to, on a very large machine, you could have something a foot wide that is there just to take off lots of material. Now that we've covered kind of the most basic anatomy of a CNC machine, let's talk about the actual process of using one. If you're familiar with 3D printing, you could be forgiven for thinking that it's the same, but it's actually quite different. In 3D printing, you download your file, you throw it in a slicer, you select the quality, you go to your machine, you load your filament, you hit go, and more or less it prints what you want, excluding any failures. In CNC milling, machining, routing, there's a lot more to it. First, you start off by designing. Sometimes people design in 3D, sometimes people actually still design in 2D. Then you go into your toolpath construction. You use software to create the paths that the head is going to have to move. That's right, it's not like a 3D printer that figures it out for you. You actually have to figure it out for yourself. You have to tell it how fast to spin the spindle, how far to move, what direction to move, and things like that. Then there's actually mounting your material onto the machine. That's called work holding. After that, you have to tell the machine where everything is. It doesn't know where everything is. And then finally, you run your job. After you've cut it, then you need to clean it up. We'll go through all that. Let's jump into it. Design for CNC. Well, it's pretty different than designing for a 3D printer. For one thing, you have to think about the fact that on a standard 3-axis machine, your cutter is coming straight down at your material, so it can't do things like get underneath the material over here. So you really can't do things like overhangs at all unless you're going to get into more complex things like moving your material around. Of course, that excludes fancier machines that have multiple axis heads. People still design for CNC in 2D. And what I mean by that is they'll open up a program like Adobe Illustrator or Inkscape, and they'll just make lines and use those as the basis for the next step. So designing for CNC is different than designing for a 3D printer. And typical tools people use for that are CAD. Occasionally, like I said, you'll see people using vector software like Inkscape, but typically they'll use CAD like Fusion, SolidWorks, stuff like that. You can design in 3D, you just have to be aware of the limitations of your machine. So after you've designed your file, you're ready to cut it. You can't just tell the machine to go. Unlike 3D printers, you have to actually tell a CNC machine exactly what you want it to do. You have to tell it how fast to spin the tool, how fast to move the tool, and how much of the tool should be engaging with the material at a time. That's a lot of stuff to keep track of. There are fancy calculators out there that can help you figure all those things out, and the manufacturers of these tools often publish kind of a best practices that you can use depending on your machine. This is often referred to as feeds and speeds. Those numbers of how fast it spins and how fast it moves, those are feeds and speeds. The general process of coming up with all of those paths is called CAM. So if you look around or Google the term CAM software, what you're doing is you're finding software that allows you to come up with those tool paths. Some software does things a little bit more automated and helpful, like in Fusion, and I believe SolidWorks also has some stuff where you can kind of choose a shape and tell it you want it to do kind of a rough milling of that shape, and it will figure out the best tool paths for you. Another thing that you have to consider when you're doing CAM for a CNC machine is the fact that it is going to have to use multiple tools most likely. Let's say you want fine detail. It doesn't make any sense to do your entire cut with a super tiny little end mill because it'll take ages and ages. Instead, you start with something big, you take away all the material you can, leaving a little bit behind, and then you come back with your tiny end mill. Well, you're going to have to go into the software, into your CAM software, and tell it, cut with this tool this way, then switch tools and use this other tool this other way. It takes a lot of practice. There are tons of tutorials out there to help you though, as well as books. We've got some books in our maker shed that'll walk you through that process. Some software for doing CAM, Fusion 360 has it, SolidWorks is getting it, SolidWorks for Makers is getting it this summer. There's PyCam, FreeCAD has a plugin that will do CAM. I think OpenBuilds also has some software that will do CAM. Lots of options out there. After you've got your tool path set up, you've done your CAM, you actually have to put your material in the machine. It sounds easy, but it's actually more complicated than you would think. This is a whole area typically referred to as work holding, where you're securing your material into the machine. Your material is going to experience forces both down and up, depending on how the tool is cutting it, as well as side to side. So you have to fasten it down really well. Typically, you see this done by some kind of clamp system, but with a CNC router, you have to be extremely careful because the cutting head, as it moves around, can theoretically hit your clamps. So there are lots of workarounds for this. I shared a tip I learned, from NYC CNC on how to do like a double-sided super glue kind of rig. There are wooden screws you can actually use to stick through sheets of plywood, so whenever the cutting tool hits it, it's no big deal. There are lots of options out there. It's called work holding, and you're gonna have to get familiar with it if you're gonna do CNC. Up next are offsets. So you've got your file prepared, you've got your material on the machine, you think you're ready to go, not quite. The thing you have to do next is tell the machine where the material is. Here in the States we call that offsets. I've heard it referred to as datums in the UK. If I'm wrong, sorry about that. But here in the States we call them offsets. When you turn your machine on, first, it's probably going to want to home itself, kind of like a 3D printer. Not all machines do this, but a lot do. And that tells it where the edge of its bed is, where the edge of its work area is. But your machine has no idea where that material is that you put in it. How would it know, right? So what you have to do is you have to tell the machine where that material is. When you are doing your CAM programming, you chose a point on your machine to be the 0 point. And that's going to be where you will tell the machine, this is that point I told you about. And then it'll kind of know where your material is. Okay, so you put a shoebox size thing in there, you told it this corner is the point you're going to do. You're going to move your machine over there, you're going to bring the tool all the way down, you're going to touch that corner, and you're going to tell the machine, this is my work offset. It gets confusing with all the names, but basically you're just telling the machine where your material is. Otherwise it would have no idea. This is also why it's extremely important that you measured your material accurately, you have the same material you programmed into it, and things like that. Your machine has no idea. It's going to run the program, and if you have, for example, a tougher material or more material than you programmed it for, it's going to crash. Now for the fun part, the actual milling. You've got the program in there, you've told your machine where the material's held down solidly, and now you get to start cutting stuff. Absolutely, it's fun. It's the best part. But there's some other stuff that goes along with that. First off, your machine has no idea what's at the end of the spindle. It has no idea what's out there. So you actually have to tell it how long that tool is. Different machines have different ways of doing this. Sometimes you program it in whenever you're doing your CAM stuff. Sometimes the machine has a touch plate where it can do it automatically. It can come down and touch something, a probe, and that tells it how long that tool is. And other times it's done at that point when you're creating your work offset, the last step, you're touching it and it knows that as far away as you are, that's how long the tool is. Now, remember earlier when I said sometimes you have to use multiple tools. That absolutely means that in the middle of your job, you're going to have to take off your old tool, put in your new tool, and tell the machine how long that tool is. For some machines, again, it's a matter of just typing it into an interface. You measure it super accurately, you type it in. For other machines, they can come over and touch off on that probe again. There's lots of ways. But it's important that you do that because if you don't, you're going to crash. After you've told it how long your tool is, you hit go, it cuts through, it cuts your shape. It's beautiful, it's wonderful. We love that part. Cutting is fun. Now real quick, before I go to the step after milling, I'm going to talk real quick about fixturing. Fixturing is a specific type of work holding. So let's say you made your object and you actually wanted to make 20 of the same object. Fixturing would be like if you made a bracket that held it just perfect so that you didn't have to go through the entire process of setting everything up from scratch each time. Fixturing is a type of work holding, but usually, again, this is extremely basic, usually fixturing is used so you can repeat a process over and over and over and over without having to come up with fresh cam and do your offsets fresh each and every time you run the job. Your job's done. Your job is cut. Now comes the cleanup. You're going to have to take it out of the machine, and usually a CNC milled piece is going to have some things that need cleaned up. Sure, especially when you get into machining metal, there are some things that you pull it out and it's just beautiful and it's done. But generally speaking, especially if you're working with wood, you're going to have to do a little bit of sanding to get rid of the marks that the tool leaves behind. Or if you're using it for joinery on woodworking, maybe you wanted it to look like traditional woodworking, so you left the inside pockets rounded and you have to go in with a chisel and chisel those out a little bit. You know, there's lots of little cleaning things to do. Even on metal machines, when you're milling, often you're going to want to deburr, you know, take that edge off of around things you cut, and maybe even throw it into, you know, a sandblasting medium or a vibrating polisher or something like that. Generally, again, it's a generalization, you're not pulling completely finished parts off of a CNC machine. So that's it. Those are the extreme basics of CNC machines. You might be more confused now than you were starting out, but I hope I answered some questions about the basics of how they work. If you're looking to buy a CNC machine, you really need to ask yourself a few questions to help narrow down so many of the options. What do you plan on cutting? Is it wood? Is it metal? What kind of metal? Things like aluminum and brass can be cut easily on a machine that is intended for wood. Things like steel and titanium, not so much. If you wanted to do wooden furniture, you wouldn't buy a CNC mill meant for metal, typically because they have a smaller work envelope to trade off for the extra weight that they have to add for rigidity. So you need to ask yourself what you're going to cut, how big is it that you're going to cut, and of course what your budget is. If you are going to be doing predominantly wood, Google CNC routers. If you're going to be doing predominantly metal, CNC mills. Like I said before, there's tons of overlap, but that will kind of get you pointed in the right direction. Thank you for joining me. I hope this video was at least a little bit useful to some of you out there who have been curious about CNC machines but haven't really dove in to figure out what it's all about yet. Be sure to subscribe to this channel, give us a thumbs up, it really helps us, and we'll see you on the next video.